Today we're going to be focusing on our triangle similarity conditions again. So that was one of your discussion questions. Many of you at least were on the right idea of what a triangle similarity condition is, but the question was name two. So that's the letters. I was looking for the letters, not the description of them, but what are the reasons that we would put that triangles are similar. So we're going to focus on those. I think we learned the third one today. You'll learn other ones, but definitely a third one. But before we get started with that, I wanted to do this as a warm-up because it's kind of like your ACT question from Wednesday. And there were some answers that were kind of alarming. I think, Jordan, you were the only one that got a perfect score out of everyone who turned them in. So good job. Like out of all three of my classes. Yeah, you're welcome. Not that like if the 5 out of 6s, they were good too. It was just like one little thing. It's probably nitpicky, but we'll see. Okay, so this is a parallelogram. So even though if you're having trouble reading this, we've already studied parallelograms, so we know all of the characteristics of parallelograms. But what is known about its sides? So for the first question in your ACT, I asked for 2 facts about the sides. 50% of the people gave me information about angles. Does that make sense? No, right? I don't want to know anything about the angles. I just said the sides. So what are 2 things that we know about the sides of a parallelogram? Yeah.
They're parallel.
So opposite sides are parallel. They're not marked on here, but we know that already about a parallelogram. And it's true because it says this is a parallelogram. So what else do we know? And these are marked on there, and it's also true as well, without needing the markings. Yeah?
Side lengths are different.
They're different, but they're different how? Like there's a step up. Are they all 4 different?
No.
Okay.
We're the same.
So opposite sides are congruent. So we have opposite sides are congruent. The tick marks tell us these 2 are equal, these 2 are equal. And then by definition of parallelogram, we know that opposite sides are parallel. All right, what's true about its diagonals? Where are the diagonals? Right, they're inside the shape. They connect the opposite angles together. So here's a diagonal. Here's a diagonal. What's true about them? Well, what do you see marked in there? Nothing? Kira, what do you see marked in there on the diagonals?
There's tick marks on the opposite diagonals, which means the opposite diagonals equal to each other, congruent to each other.
By opposite, what do you mean?
Like connecting lines.
Oh, okay, yeah. So you're saying like these 2?
Yeah.
Yeah, so these 2, since they have 4 and 4, these 2 are equal. 3 and 3, these 2 are equal. Does that mean that this diagonal is equal to this diagonal? No, right? We don't have any information telling us that. If these would have all been 3 or these would have been all 4 tick marks, then yeah, they would have been equal. What else do you know about the diagonals? Yes.
Right.
Yeah, they intersect at a right angle. So that means right angle. One of the questions or answers I got a lot about the diagonals where they were parallel. What does parallel mean? They don't touch. So it wouldn't make sense to say the diagonals are parallel to each other because they do intersect, and they intersect at a right angle. So therefore, what type of lines are they? What type of lines intersect at I just said it, perpendicular. They're perpendicular. So lines that intersect at a 90-degree angle are perpendicular. But for yours, I accepted. Some people said they were different lengths, which was true. I told you they were 10 and 20. I think some people just said they intersect. That's fine. That's true. But I didn't accept that they're parallel. What shape is made by the diagonal? So you said it. Right, a right triangle. How many right triangles are there? 4. You think it would be appropriate to just say triangles were formed? No, right? That's not specific enough. So right triangles were formed. This should be, how do you find the area of a parallelogram? What's the formula? Oh, everyone should know this. How do we find the area of a parallelogram? Base times height. Good. Base times height. So that's what I was looking for also on the ACT. It's a rhombus. Rhombus is a parallelogram, so it's base times height. So this one, to find the area, since it was base times height, we need the outside parts, right? To find the inside part. Area means inside. You need to know the sides of the parallelogram. That sounds called right. What formula would you use to find the sides of this parallelogram? So Kylie pointed out that there are right triangles. Are you given information about anything on the right triangles? Yeah, so there's 3 and a 4, right? The legs are 3 and 4. We need this part and this part. Pythagorean theorem, right? Pythagorean theorem is going to help you find the side. I'm still getting the answer of an area formula. Can you find a missing side by using the area formula? Nope, you can't. Yeah, if you were given the area and one side, then yeah. But if it's not going to help you. If you find the area formula for this, you do 3 times 4 divided by 2, you're just going to get that the inside of this is 6, but the length of this is actually going to be 5. So area means the inside. It doesn't help you find the side. So that's 2 weeks now that I've seen the area formula being thrown out there to find a missing side. We don't do that. Missing side, if we have a right triangle, we use Pythagorean theorem. If not, no, we're out of luck. We need more information somehow. Okay. So for today's lesson, I gave you the resource sheets. You can take whatever notes on there if you want, but it's kind of like, I mean, it's still CPM. I just may not follow along with what this is. So what triangle similarity conditions do we have so far?
SAS.
Right, SAS and AA. What does SAS mean?
Side equals side.
Right, and AA? Right. Okay. Let me go ahead and label. Let's start with angle. I'll do it like this. All right, so this represents angle. We have 2 pairs of congruent angles in there. So we automatically know the third angle has to be congruent. How would I write the triangle similarity statement? Austin, how would we write this triangle similarity statement? That's a triangle similarity condition, so what would the statement be? Remember the flow charts where we did the 3 facts? And then there was something underneath it? What was the big bubble? We had, for angle, we would have these 2 things. That leads to these 2 things. And then AA would go there. What goes in here? Help?
Chain ABC.
Not the change, not science.
Well, it has the little triangles on it.
Yeah, but that doesn't mean change in here.
I thought it was a delta.
It's not a delta. It is a delta in science, but in here it's not. It's a triangle.
And it's just the angles of ABC, right?
No. Triangle.
Okay.
You have to say triangle.
Okay.
I get it. I do it because I'm taking chemistry and I write triangles all the time for change. But yeah, triangle ABC is what?
Congruent.
Oh, is it congruent? Similar to? Right, BBF. And then this, it was proven by angle-angle similarity. So triangle similarity statement, you write the two triangles that are similar to each other, making sure that the angles match up to each other in your statement. Okay? All right, then we have side angle side. So this represents side angle side. We have two sides that are proportional to each other, and the angle in between them are congruent. So since I have a picture that looks like side angle side, do I go ahead and just say, yep, it's side angle side? No, what do I have to check? So what?
If there's an angle,
Okay, so what angles are congruent to each other?
A and B.
Okay, so if we were doing a flow chart, we would write angle A is congruent to angle B. Then what's next?
Side A and B.
So use the numbers.
Oh, side 2
Uh-huh.
and side 2. Side 2, side
So
1.
these two go
Oh,
together,
side 1.
right? So what am I gonna write using 2 and 1?
Side 2 over side 1.
Right, so 2 over 1, what's this thing called?
Ratio.
It's a ratio. So what's 2 over 1 equal? 2. All right, what's the other thing I'm putting in here? 4 over 2. So I have another ratio. So in looking at our ratios, I put corresponding sides into the two ratios, and then they both equal each other. So therefore, what kind of ratios are these? Use your vocab words. They're common ratios. So that was one of your discussion questions. How do we use common ratios, and what must they be used for? They are taking the corresponding sides of the triangles, putting them into a ratio, and then they have to be equal if you have similar triangles. I got a lot of funky answers on that, but that's okay. I think I knew what you were talking about. Okay? So all of those facts are true. Also, what am I putting in here?
The triangle AB.
Yeah.
ABC is similar to triangle B, yeah.
Right, good job. And the reason why these two triangles are similar? Right, it's side angle side. So angle, angle, side. Today we want to look to see if there are any other ones. So angle is the easiest, right? There's only two things you have to check. We don't have to put any ratios in there because it's just angles. We know that they have to be equal to each other. This is always true because definition of similarity says all angles have to be congruent, right? If you have that, then all the sides have to be proportional, and that's the second part of the definition of similarity. So this Rogel guy says that side angle side is too much work. He doesn't want to check all of that stuff, and he wants to know, will side-side similarity work? Draw that. Draw side-side on your paper, what that would look like with two triangles. So you're drawing two triangles representing what side-side similarity would look like. Side, not angle, angle. You got two angles. What's what are sides? And then we have to have numbers there. All right, so if we were looking at side, that means we have information about two sides only. So this would be an example of side. I have two sides that are written here, and they are proportional because if I divide by, or if I multiply by 1/2, I get 1, multiply by 1/2, I get 2. So those two sides are proportional. So does side work? Meaning, if I were to check this side proportional to this side, which yes, so 2 to 1 gives me 2. And then this side proportional to this side. So yes. Does that mean that BC over EF has to also equal 2? Meaning, when I have those two sides, do they have to stay like this, or are they allowed to move in any direction they want? Or does that third side have to remain still and be proportional? What do we think? Gavin, what do you think? Yes or no? Will side work? You're saying no. Kylie, what do you say? No. Jordan?
No.
Nick? No. Austin? Okay, why are we saying no? You know I'm going to ask you why. What's our reasoning? Or did we all just go with what Gavin said? Kylie?
Is it wouldn't be equal if the last side is the same?
What'd you say? Sorry.
It wouldn't be equal if the last side is the same.
What was
So like the sides, so if you keep changing them, like moving the direction and the you change the
Yeah, exactly. So I had this side's proportional, and this side has a proportional side. It matches with another triangle. But there's no angle here keeping it the exact same distance from each other. So since there's no congruent angle in between these, then I'm allowed to move my hands whatever direction I want, which means this side and this side could be whatever I want and once, and these could still remain 1 and 2 and 2 and 4. Does that make sense? It doesn't make sense to you? What I said?
I thought they couldn't move because
But they can't move if this information was given to you.
okay.
But it's not there. There's nothing there but two sides. So since there's no angle in there that's congruent, they're allowed to freely move. There's nothing holding it in place. Even if I put the angle here, what would that look like? Let's say that there is a congruent angle, but it's right here. Is that angle holding these two sides in place? No. So does this work? No. Okay. What if I move it over here? Is this angle holding our two proportional sides in place? No. So it matters where that angle is, but since we don't have an angle, will side-side similarity work? If you have two pairs of proportional sides, can you say, yes, these two triangles are similar by side-side? No. It works for angle, because angles are what keeps it the same shape. So by the triangle angle sum theorem, if this angle and this angle have taken up a certain amount, then there's only another amount that this can be, one amount, and that's it. So if we know two pairs of angles are congruent, then yeah, this one has to be the same. These two triangles are similar. If this side is proportional to this side and this side is proportional to this side, it doesn't mean that those two sides have to be proportional. If we revisit the triangle angle sum theorem, or triangle inequality theorem, we know that the biggest side has to be less than 6. Sorry, wrong way. Biggest side has to be less than 6, and the smallest side has to be greater than 2. 2x 6. For this one, biggest side has to be less than 3. Smallest side has to be greater than 1. So an option here for this side could be 5. And an option here could be 2. And 5 and 2, 5 divided by 2, is that 2? No. So do you see how side doesn't work? It's not enough information. Because that third side can be any number in between whatever the triangle inequality theorem states. So an angle is pretty important most of the time. So then let's try to come up with some new ones. What parts of the triangle do we use to prove congruency or similarity? Angles and sides. So we've been using the letters A and S. We have angle, we have side, side. Well, how many pairs of sides are there? 3. How many pairs of angles are there? 3, right? So then how many total letters could we write in a triangle similarity condition? 6. So we have right now one that has 2 letters. We have another one that has 3 letters. But are there other ones for us to discover? So on your paper, I want you to write down combinations of sides and angles that you think might work for a triangle similarity condition. So just write as many as you can think of. You're just writing a bunch of S's and A's. Yeah, so you're just making combinations of letter. Like we have an angle, and we have a side, side. Are there other ones for us to discover? And you won't know them, so we're going to test them out. It can't have more than 6, and it can't have more than 3 A's or 3 S's. I'll come around. I know, I probably because of this. You can fix that. I wanted to so what should we do? Yeah, but they're only once a week. All right, Gavin, give me one of your combinations.
ASA.
ASA. Kylie, give me one. SSS. Jordan.
AAA.
Nick. Austin.
AAS.
You already write that one? No. All right, Kira.
ASAS.
Lana.
SSA.
Gavin, do you have any other ones? No? Kylie? Jordan?
You can literally just do SSS.
Okay. Anyone else have other ones? Really? No one had that one? You have it?
I thought of it, but I didn't say.
You want to say it?
ASS.
When are you going up there?
Huh?
When is the last one are you up there?
No.
It's just looked around.
Oh, SSA? Yeah, well, we should see if order matters, right? Okay, anything else? That's all you want to check? All right, let's go through and check them. So, I wrote the ones that already work in green. So angle, angle works, side, side works. This would be angle, side, angle. What do you notice about the letters in this one in comparison to this one? Huh?
That's
Okay, what do they have in common?
doing.
Right, they have two angles. And we said that if they have two angles congruent, aren't they automatically similar? Yes. So this one has two angles in there that's congruent. So do we need to check to see if the side in between them is proportional? No, right? It's not wrong, but we don't need it because if you already have angle, angle, you don't need to go the extra step. So if you do go the extra step in your flow chart, it's fine. But we don't absolutely need that one. Side, side, side. What are we thinking? What's the definition of similarity? Same angles and what? Proportional sides. So if all sides are proportional, does that mean that the two shapes are similar? So again, definition of similarity says all angles are congruent, all sides are proportional. So if you have all sides already proportional, are the two triangles similar? That doesn't make a triangle, does it? Well, that doesn't make a triangle, but whatever. We'll go with it. So we now have 2 goes with 1, 4 goes with 2, and 6 goes with 3. Do we have all common ratios? Yes. So does this mean that this triangle is similar to this triangle? Does it, so for it to be similar, all sides have to be proportional and angles are congruent. So are these angles congruent? Oh, we do know. Remember this? If this angle is congruent in here, and these two sides are proportional, the only thing left is for this side to be proportional as well, right? Because it can't move. So we can do it in all 3 spots. Can my sides move? No. So yes, the angles are congruent. So side, side, side works. You have to have all 3 sides. All right, what about angle, angle, angle? Will it work? Yeah, it'll work. It has 2 A's in it. It works. Do we need it? Do we need the 3rd one? No, but it works. What about side, side angle? Side angle. That would look like this. This works. So remember, if you're missing the third side, in order for these two not to move, the angle in between them has to be congruent. Is the angle in between those two proportional sides congruent? The way this is drawn, this side is proportional to this side, or this side is proportional to another part, this side is proportional to another part. Is this, can I move them? This angle is in between these two sides, right? Is it marked congruent to any other angle? So can I move these sides? Yes, it gets to move. This angle is not in between the two sides. It's congruent. So it doesn't matter. So this will not work. Side angle will not work. And as Gavin pointed out, that's the same as this one. Math wouldn't allow us to cuss, so that's why that doesn't work. It'd be cool if it did, but no. What about angle, side? Is it true or false?
True.
Why?
2 angles.
Right, it's got two angles in it. It's got to work, but we don't need that third side. What about angle, side?
True.
True, but do we need to write all those letters? No. Okay, what about side, angle? It's true again because the two angles, but we don't need it. The same's going to go for this one. So really, these are the three that we need. Angle, side, side. So we now have a third one that we can prove. And we actually kind of did that on, was it Thursday, the one that I had the moving parts? Yeah, Thursday or Friday. But ours wasn't similar, but we did use side. So similarity, you have 3 conditions. When you get to congruency, there are 6. But right now, there are 3 that we need. So again, they're angle, side, side. Tomorrow, we're going to do more work with the flowcharts using all 3 of those conditions. Did I tell you? Oh, yeah.
Would side angle?
Side angle? Okay. So if we had this, right, this would be side angle. I have this side proportional, and I have this angle right here. So I'm going to put it like this, but this guy, I'm going to do it like this, because this guy, we don't know its measure, right? So since this is the angle that's congruent, is there anything stopping this side from growing or shrinking? No. So that's why side angle won't work. It's on the track of working if you put a side in there, but side angle, we need more information. So it's not so much it doesn't work, we just need something else. Good question though. Did I talk to you guys about how homework is going to change? Okay, so I don't think this homework is really doing you any help. I'm not getting too many. I've probably gotten 2 questions all year about the homework, and we're in week 4 of the second quarter. And I know some of you are actually working through it, but others are just straight copying it each time. I know you can copy and paste and find the answers to the homework. I do it myself on some of my chemistry work when I'm needing help. And yeah, like while it's good in a pinch when you're in a rush, it's not helping you learn anything. So it's going to change to where you're going to have to watch videos to get the homework question. So it may be in the form of an ed puzzle. It may be in the form of me just doing a recap of whatever the day's lesson is, and then I start your homework problem for you, and you have to answer it. You may have to answer it on paper. You may have to do a Flipgrid video. Now, I know a Flipgrid video can be, I know. How do you think I'm recording this lesson, knowing it in my head the whole time? I know that it can be very high anxiety, but remember when it's a Flipgrid video, I'm the only one that sees it. It automatically sets to only me can see it. Like only me, only I can see it. Like Jordan can't go on there and see your video. It just automatically sets to it's not public or it's not viewable. So the reason I would do a Flipgrid is because I want to hear you explain. There's too much that we're trying to say answers, but not understanding the background of it. So I may even change the test to be like that. Like, I don't know that I even want tests anymore where you're just solving the problem. Like, I want explanations. I want you to understand the why. Another reason that I'll do it that way too is because when some students are quarantining or when they're just not here, they're not doing the Desmos lessons. They're just doing the homework. They're not watching the other videos, and you're not learning anything. Because when you come back, am I reteaching all of those lessons that you didn't do? No. And it doesn't work in math. Math builds on it. Social studies, yeah, you can get away with it because you don't need to know previous information. But with math, you can't do it. So that's why it's going to change. So be ready for that after break. So we're still doing this today and tomorrow. And then I don't have it for next week. I'm not going to do it. We'll do a lesson, but you don't have the homework for it. You'll just have a discussion question and a lesson, and that's it for next week. Okay. Done with that.